What was the topic we looked at last class?
Indices.
Indices. Okay. So today we want to look at logarithms. We want to look at logarithms. So, logarithms has an aspect that relates with indices, in the sense that as we looked at the laws of indices, we are also going to look at the laws of logarithms. Is that taken?
Yes, sir.
Okay,
Yes,
very
sir.
good. Said, you are welcome. How are you?
Fine.
Okay, good. So we want to look at the laws now. Laws of logarithms. And the laws, first two laws also are synonymous to that of indices. Like in indices, we had what we called product law and like addition law, subtraction law, product and so on. So here, the rule one we're going to have under logarithm, because log is an expression of numbers. Like you can say you have log A to base B. This is an expression of log. So let's talk about the rules now. Rules. Rule number one. If you have something like log m times n to base b. So let me say log m times n together to base b. You can split this and say this is equal to log m base b plus log n the same base. That means here it's like we factorize to have the left hand side, and it's like we expand to have what is on the right hand side. Are you seeing that?
Yes, sir.
Yes, sir.
Okay, very good. And number two, we're going to apply the rules in examples later. So rule two is if you have something like log m divided by log n, log m over n to base b, then you can say that is log m base b minus log n base b. And we have a third rule here. Third rule says if log of a number is raised to a power, that's like the product or whatever. So power law, that is log m raised to power k base b. Now let me write that k as small as possible so that it will appear like a power. So log m raised to power k base b is the same thing as not b now. Same thing as k multiplied by log m to base b. K log m base b. And the fourth rule that you're going to have there, are you seeing the rules?
Yes, sir.
So you can put them down straight away so that we can go ahead and move on. So the fourth rule says log 1 any base is 0. log 1 log 1 to any base is 0. So let me write it here. Log 1 to a particular base is 0. So if I give you log 5 is 0. Log 1 to any base, log 1 to base 5, log 1 to base 10, log 1 to base 1000 is 0. So as much as it's log 1, it is 0. So number 5. And this rule says log of the same base is 1. Log of the same base, that is log b base b, must give me 1. Log of the same base is 1. So log b base b equals 1. So, and we have about 2 more rules there, about. So we have log of the same base raised to a particular power equal to the power. Log of the same base, that's number 6. Log of the same base raised to a particular power. Log of the same base raised to a particular power equal to that power. And you can see from here, we have the one that says that k should come to the back. So if the k should come to the back, it's going to be k log. It's going to be k log b base b. And since log of the same base is 1, then we have b times 1, which is b. Which is k rather. We have k times 1, which is k, not so we have k times 1 because log b base b is 1. Your final answer to this one is k. And the final rule on that page there says b raised to power log of base b log of k base b equal to k. Let's see that. So if we have b raised to power log of k base b, then this equal to k. So we're going to look at how we're seeing this in examples to be able to solve them. So put that down, please. So are you through with that now?
Yes, sir.
Okay. So the two of you, is it the two of you that are true?
Yes,
Two of you are
sir.
true. Ezekiel, are you true?
No, sir.
Okay. So for all of these laws, we said all our base must be greater than 0 and must not be equal to 1, while all the other alphabets are real numbers, which must be positive. The number m and the n that we have used must be positive numbers. So let's take note of that. And there is another part of the log, which I will say, like if you have log b base a, you can take a common base 2. Log b base a, let's say, let me name that as like 8. Log b base a can be equal to log b base c divided by log a base c, base c. That is, you take a common base of the two that are here. Also, we have stated that log 1 base, log 1 to any base is 0. Log of the same base is 0. Power of the same log is equal to that power. So if I have something like log 1 over b base a, log 1 over b, log 1 over b base a. From our indices, we know that 1 over b should be b raised to power minus 1. Okay, then we can say this is minus 1 log, because the power has to come here. So minus 1 log b base a, which is the same as minus log b base a. Are you getting that?
Yes.
Okay. Then if we have log of base b raised to power, log b base 1 over a. Log b base 1 over a. Like number 10 here. Log b base 1 over a. We can also say, since log b, this could be base a raised to power minus 1, and this minus 1 also can come to this side, but it will be 1 over the minus 1, which is still minus 1. So we now say this is, or let me put minus 2 here for reference purpose. So it will now be 1 over that negative 2 log b base a. But it being it was minus 1, it will now be 1 over 1, which is already minus 1 there. Do you get that?
Yes.
Okay, so that is minus half log b base a. Minus half log b base a. Okay, so those are the laws that we want to look at right now, except that just want to say this, that let me put past the 11th one and say if you have log a is b equal to c, you can rewrite this expression by saying a equal to b raised to power c. If you have log a base b to be equal to a particular c, then we can say a equal to b raised to power c. So, are you through with what's on the board now?
Yes, sir.
Are you both through?
Yes, sir.
Okay, very good. So let's look into a few examples. The first example I have here says to simplify log 24 base 6 plus 2 log 3 base 6. Let me clean this that we can look into examples. We want to look into example now, so we're going to start with example 1. So for example 1, I have log 24 base 6. Example 1. Log 24 base 6 plus log 24 base 6 plus 2 log 3 base 6. 2 log 3 base 6. I want to advise you not to write anything at this junction. Both of you should stop writing and look at this, okay? That's taking very good, so that you will not have the cost to be saying, how did you get this or how did you get that? So let's solve this together. Now this is log 24 base 6, and this could be rewritten as log 3 square base 6. Where did I get the square from? From the 2 that's at the back of the log. You get that?
Yes.
That is from one of the laws there. That if you have power, it can change to coefficient, and if you have a coefficient, it can change back to power. So here now, we say this is log 24 base 6 plus log 9 base 6. Yes or no?
Yes.
Very good. And from the first law that gave us addition, the law said we can combine. So we can combine the base, take a common base 6. Then we now say 24 times 9. We say 24 times what?
9.
9. Because it's addition, so we can multiply. So what is 24 times 9 there? That should be 216. So this will be that's already written. So this will be log of 216 base 6. Are you with me?
Yes.
So now we can say this equal to log. You can see 6 is a factor of 216. In fact, 216 is the multiple of 6. So I can say 6 raised to power 2 is 36. While 6 raised to power 3 is 216. So I can say 6 cubed base 6. Then because I have 6 cubed here, the 3 can come to the back. Then it will now become 3 log 6 base 6. And what is log 6 base 6 according to the rule? It says 1. Yes or no?
Yes.
Log of the same base is 1. So since log 6 base 6 is 1, then I have 3 times 1, and my final answer is 3. Is that clear?
Yes, sir.
Are you sure? Are you sure it's clear?
I don't really understand this place.
This one, right?
This down here.
Okay.
Yeah.
You understand the first step? Let me mark that. Do you understand this step?
Yes.
Okay, you understand this place?
Yes, sir.
Okay, here 24 times 9 is 216. You get that?
Yes, sir.
And you can bear me witness that 6 times 6 times 6 will give me 216. Do you get that?
Yes, sir.
Aha. And this 3 has to come to the back according to the rule. You get that now?
Yes, sir.
And when you have the same log, 6, 6, the answer must be 1. So all these log 6, whatever is 1. That's why 3 times 1 here. Then the final answer is what?
3.
Now, is that clear now?
Yes, sir.
Okay. Probably we can look into one more example, but I advise that you watch the video again so that you can get clearer understanding. Okay?
Yes, sir.
So let's look into one more example. This example says log 9 base 5 plus log 4 base 5.
Curriculum organization.
So have you written that?
Yes, sir.
Okay. I want to move to a second example now. So there is another aspect of logarithm that we require you to be using four-figure table, but that will do it for later, not now. Okay.
Okay, sir.
All right. So example 2. Example 2 says log 9 plus log 4 base 5. Log 9 base 5 plus log 4 base 5. So whenever you see addition, just combine it. That's all. That would be log 5 times, not 5, log 9 times 4.
9.
Yes. Log 9 times 4 in bracket and base 5. And this is going to be log 36 base 5. And since 5 is not a factor of 36, then this becomes your answer. Okay?
Yes,
Very good. So let's look if we can do one more example. This one says 4 log 0 base 6. 3. Example 3. 4 log 6 cubed base 6 plus 3 log 8 raised to the power 4 base 8. 3 log 8 raised to the power 4 base 8. Now you can see that we have the same base here, we have the same base here, but these powers must give way to the back of the log. So for the first one, I have 4 times 3 log 6 base 6. And the second one, 3 times 4, then log 8 base 8. Then this is 12 log 6 base 6 plus 12 log 8 base 8.
okay.
And since the log of the same base is 1, then I have 12 plus 12, and that is 24.
24.
Do you get that now?
Yes, sir.
Saeed, do you get that?
Yes, sir.
Okay, very good. So put it down and let me know when you are through. If probably be able to look at one more example or we can move on, or a few more questions. Let me explain the first example again. So are you through now? Are you through writing now?
No, sir.
Okay, write it down. Write it down.
Could give me another pen.
So another example here is example 4. This one says evaluate log 8 base 2. Log 8 base 2. Are you with me?
Yes, sir.
Now look at this, please. Don't lose focus on this. Whenever you see anything like this, all you need to think of is that just say it is equal to something like x. Then you go and follow that our last rule, which says if you have log a base b equals c, you can rewrite it as a equal to b raised power c. Now, if this law is representing this question, what is my a
8,
and what is my b
2,
and what is my c?
X.
Very good. So if I want a equal b raised power c, that will become 8 equals to what?
Equals
2 raised
2
power
raised to
x.
power X.
Then you look at what what will 2 raised to power to give me 8. That
Ah,
means 2 raised power 3 equals to 2 raised to power x. 2 raised
X.
power 3 is 8, yes or no?
Yes, sir.
So if 2 raised power 3 gives 8, then I can relate x to be 3. I can relate x to be what?
3.
That means x equals to 3. So therefore I can say log 8 base 2 equal to 3.
3.
That is the answer there. You get that?
Yes, sir.
Very good. So let's look at one more question right now, then call it a day. Let's look at one more question,
My leg.
call it a day. So that is how to solve some questions on logarithms. So this question says evaluate log 32 base 2. That's number 5. Number 5. Log 32 base 2 equals to what? So just say log 32 base 2 equal to x or c or any letter equal to y. So I can say 32 equal to 2 raised power y. Then 2 raised power 5 is 32 is equal to 2 raised power y. Then y equal to 5. That means I can say log 32
Sir,
base 2. Yes.
where do you get this 2 raised to power 5?
Yes, 2 raised power 5 because it is 2. I will multiply. I will look for a number that will multiply itself in how many places? This number is 2. Yes or no? The number outside is 2.
Yes, sir.
So I will say 2 in how many places will give me 32.
Okay.
2 multiplied by itself in how many places? Because it's power I'm looking for. Yes or no?
Yes, sir.
So 2 multiplied by itself in how many places is going to give me 32. That means in 5 places. That is 2 times 2 times 2 times 2 times 2. And that is 32.
35.
2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is what? So that's where I get the 5 from. Is that clear now?
Yes, sir.
Okay, very good. So do you enjoy the class today?
Yes, sir.
Okay, so by the grace of God, we'll meet for English class tomorrow. I think before the end of the day too, I should make the video available. So I'm going to stop sharing the board now. Thank you very much for today's class. Do have a nice day, okay?
Yeah.
All right. Bye.